I forgot to say on the previous video, it worked out well. That's because we used u equals sine t the first time and u equals cosine t the second time. We stuck with trig both times. If we had done sine t the first time and then switch away from trig to exponential, we would end up accidentally undoing the first integration by parts. We would end up with stuff equals 0 plus stuff, which is true, but doesn't help us at all. So using liate helped us keep consistent in that and not accidentally undo the work we had just done. All right, let's try a new problem. Integral of log x. You might be saying, oh, well, that's one of the basic facts, right? Is the integral equal to 1 over x? Well, what do you remember about the derivative and integral rules? Nope, that's not true. What is true is the integral of 1 over x dx equals log absolute value of x, or log x derivative equals 1 over x, but neither one of those is integral of log x. So what should we do? Integration by parts. So what would you choose for your u and your dv here? Let's think about liate. Well, I see a log sitting right there, and that's the first thing in liate. So we'll use u equals log x. And then what is dv? Well, there's nothing else left in the integral once I've chosen u other than the dx. Some books like to point out that it's kind of 1 times dx. That's not a bad way to think of it. And then what's the next step here? Go ahead and do that. You'd have du equals derivative of log is 1 over x. And what's the integral of 1 dx? That would just be x. So now write out the integration by parts formula and fill out the separate parts. So we have u times v minus integral v times du. U is log x, v is x, minus the integral of v, which is x, du, which is 1 over x dx. So we'll still have log x here times x minus, now the x cancels the 1 over x, and we get just 1. And that's a pretty easy antiderivative to take. You just get x plus c. And then what's the next step there? Check it by taking the derivative. So we take the derivative of that whole thing. So we'll get what? Log x prime times x plus log x times x prime minus, and then this x becomes x prime. Log x derivative is 1 over x times x. Log x times 1 minus derivative of x is 1. Oh, this should be a plus. And then we can cancel those. And then that whole thing is now 1, which cancels that. And we're left with just log x, which is what we wanted. So it feels a little unusual to begin with to say dv equals dx or dv equals 1 dx, but it all works out kind of like liate had us gave us a hint toward using that the log as the first thing.